Hello. In this video today we'll discuss about the equations of motions which will derive from the graphical representation. So as you know, there are three equations of motions that are very important. And V is equal to U plus at V square minus U square is equal to 2s, and s is equal to ut plus half at square. So these are three equations of motion. They are the equations of motion. And what are the letters, like what are this B, U and T? So these are the, like V is the final velocity, U is the initial velocity, A is acceleration, and T is time. Okay, so these are the relationship between U, V, A and T, and of course this S is the displacement. So these three equations of motions will derive from graphical method. So to derive this graphical method, we will use the concept that is the area under velocity time graph gives you the displacement. What concept we will use? Area under velocity time graph. Suppose this is a velocity time graph. So area under this graph, this area will give you the displacement. So area under VT graph will give you the displacement S. Okay, so with this concept we will derive all the three equations. Okay, so let us calculate one by one. Let us derive the first equation, or you can say the first, this is the relationship. So V is equal to U plus AT. So let us derive first this one. And we are deriving this equation of motion from graphical presentation or graphical method, using the graphical method. You can of course derive this equation using calculus method also. In some other video I'll also explain how to derive this equation of motion using calculus method. So today we will derive it from graphical method. This question is an important question in your secondary or high school physics. So let us draw a x-axis and y-axis. From the coordinate geometry concept, you know, the right side we generally consider as a positive x-axis, and the y-axis above the origin we consider it as a positive y-axis. Let's say this is 0 origin. So here in the x-axis we will consider time, and in the y-axis we will consider velocity. Now in this velocity time graph, let's say the object started from u means the object started from with initial velocity, certain initial velocity, let's say u. Okay, not from 0. Here the 0 point, that means if the object starts from 0 speed, then we can say the object starts from rest also. So here the object starts from certain initial speed, let's say 20 meter per second or 30 meter per second, whatever, but it has certain initial speed, so it starts from u. Okay, and the final speed we will consider, right? Suppose it reaches at final speed v within this time. Within what time? This time, let's say t. Okay, so the object changes the speed from initial speed u to v within that time. The time it takes is t. Okay, so to derive the first equation, we will consider the case of here the definition of acceleration. What is the definition of acceleration? The definition of acceleration is the rate of change of velocity is the acceleration. So here, what is the change of velocity? The change of speed velocity is from u to v. So the change of velocity is v minus u, and this change occurred in the time duration t. So divided by t, the rate of change of velocity is your acceleration. So from definition of acceleration, we can write that v minus u upon t, or if you cross multiply this t here, then you will get v minus u is equal to 8t. Or if you will further simplify it, you will get v is equal to u plus 8t. This is your first relationship, that is v is equal to u plus 8t. Clear? Okay, so this relationship is your first relationship. Now let's discuss about the other two relationship. So other two relationship we will get using the concept of area under velocity time graph. As in the beginning of the class I have told you that area under velocity time graph gives you the displacement. So in both the next two equation you will have the displacement in the equation. So in both the cases we will discuss about the area under velocity time graph. Let us erase it and draw me again this graph. So the object suppose starts from initial speed u, reaches at final speed v, and this change in speed occurs in time duration t. Now let us join this one, a perpendicular from u. Okay, now the total height is v. From here to here the height is v. From coordinate geometry you know this is the v, and here this is u, this height is u, so this will be u. The full is v, so what will be this distance? This will be of course v minus u. Okay, because total is v, from here to here it is u, because this is parallel, right, rectangular, so if it is u, this will be also u. Now we have to calculate, as I told you, that area under velocity time graph. So in two ways we can find out the area. So okay, so what are the two ways? One way is you can look here, it looks like a trapezium. It looks like a trapezium. See, there are two parallel sides. Okay, two parallel sides are there, this and these two parallel sides. Okay, so so it looks like a trapezium. So using the formula of trapezium, you can find out the area under this velocity time graph. Okay, and the second way you can find out the area under this velocity time graph is you just divide it, then this will form a triangle, this will form a rectangle. So what you will do, the area of this triangle plus area of this rectangle will give you the area under velocity time graph. Okay, so in two ways you can find out the area of this diagram or area under this velocity time graph. So let us first use the area formula of a trapezium directly. Okay, so let me name this trapezium, that is suppose A, B, C, D and E. Okay, so in this trapezium, the area of this trapezium ABCE, area of this trapezium ABCE, what is this area of this ABCE trapezium? So the area of ABC trapezium is equal to what? What is the formula? The formula is half into height into sum of parallel sides. Half into height into sum of parallel side. A and B, let's say these are parallel side. H is the height. So half into, here height is, let's say this BC is the 9 perpendicular one, so it can be height. So this BC here represents the time. So in place of height I can replace one time. Sum of parallel side A plus B. So what is A here? Parallel side. Parallel side, this is one side, this is another side. So this side is U, this side is B. Okay. So sum of parallel side is U plus B. Clear? Now from the concept of acceleration we can replace this T. Okay. We can replace this T. How will you replace? Because we know that V minus U by T is equal to A acceleration, definition of acceleration, or T is equal to just cross multiply V minus U by A. So what you will do, will replace it, that is half into T I will write as V minus U by A. I just cross multiplied, and U plus, or I will write V plus U. U plus V is same as V plus U. Now you can see in the numerator V plus U into V minus U. So you know this formula, A plus B into A minus B. What is A plus B into A minus B? A plus B into A minus B is A square minus B square. So same formula will use, B plus U minus B minus U. So B plus U into B minus U will be equal to half into, okay, V plus U into V minus U is V square minus U square by A. And what is the left hand side? The left hand side is the area of ABC trapezium. So area under this ABCD trapezium will be your displacement S. Okay, that I have told you. Area under this graph, area under this velocity time graph will give you the displacement of the object. So now I will write it, final equation. This 2 into A in the denominator here will multiply them, will cross multiply here, and will simplify it. So it will be 2A, it will be 2A 2as is equal to V square minus U square. Okay, clear? This is the second equation. Let me write clearly. So what is the equation we got? The equation we got is V square minus U square is equal to 2as. Okay, B square minus U square is equal to 2as. So this is your one of the second equation, let's say. So now we'll discuss the final equation or the third equation. So as I told you, the third equation, how will you do it? By taking into consideration the sum of the area of triangle, sum of the area of the rectangle. Using this concept we will get that equation. So how will you do that? Let's begin. So as I told you, this will be, the total is V, so this will be V minus U. Now what is the area under this velocity time graph? So this will be area of triangle ADE, triangle ADE plus area of rectangle ABCD. Okay, so this will give you the displacement. So area of triangle AD is what? Area of a right angle triangle is half into base into height. So half into base. What is base? Base is b minus u. B minus u half into base into what is height? This height is your time. Okay, that is AD. So height is time, half into base into height, plus what is this? Area of ABCD. Acha, ABCD is a rectangle. Rectangle area is what? Base into height. So, or you can say length into breadth. So here it is u is the breadth and length is time. So u into t. So what we got? We got this relationship, that is S is equal to ut plus half into, acha, what is v minus u? From here, from this relationship, that is v minus u by t is equal to a. So v minus u will be a into t if we will cross multiply. So I will replace v minus u as at, and 1 t is there already extra into t. Now you will get the third equation. So what is the third equation? Or last equation, that is s is equal to displacement is equal to ut. U is the initial speed, t is the time, ut plus half at square. Okay, so what is the summary of our discussion? The summary of our discussion is that we derived the three equations of motion. Okay, the first equation of motion that we have calculated using the basic definitions of the from the basic definition of acceleration, that is your we calculated, that is from basic definition, that is v is equal to u plus at. So this equation we calculated from your basic definition of acceleration. And the second equation we have calculated using the area of trapezium. Okay, from this velocity time graph we have calculated the uh, area under this velocity time graph. Okay, using the area of a trapezium, that we got is v square minus u square is equal to 2as. And the third equation of motion, that is s is equal to ut plus half at square. This equation we got taking into consideration that this is a this area under this velocity time graph is sum of two areas, that is one right angle triangle and another rectangle. So taking into consideration these two shapes, we have found out the area individually and we have added them. By adding them, we got that s is equal to ut plus half at square. So these are the three important relationship or equations of motions, and using these three equations of motions, you can solve many questions. In some other class, I will also solve some questions, some numerical question. Thank you for all for watching this video. Thank you all.